How do CI/CD pipelines work with microservices architecture in SaaS? Have you ever wondered how software companies keep their applications running smoothly while constantly updating them? The answer lies in continuous integration and continuous delivery pipelines, or CI/CD pipelines for short. These pipelines are essential for managing software changes efficiently, especially in a microservices architecture within software as a service environments. So, how does this all come together? First, let's break down what microservices architecture means. Instead of building a large, monolithic application, companies create smaller, independent services that each handle specific tasks. This modular approach allows teams to work on different parts of the application without stepping on each other's toes. Now, that's where CI/CD pipelines come into play. Each microservice has its own dedicated pipeline. This means that when developers make changes to a microservice, they can test and deploy those changes without affecting the entire application. This setup supports faster releases cycles and greater agility, which is crucial in today's fast-paced software market. The process begins with continuous integration. Developers frequently merge their code changes into a shared repository. This triggers automated builds and tests, ensuring that any issues are caught early. Once the code passes these tests, it moves to continuous delivery. Here, the code is automatically deployed to staging environments for further validation. In some cases, continuous deployment takes it a step further by releasing changes directly into production without manual steps. Key features of these pipelines include service-level pipelines, which allow each microservice to manage its lifecycle independently. This reduces bottlenecks and enables parallel development. Deployment strategies like blue-green deployments and canary releases help ensure that new versions can be introduced safely, minimizing downtime. Containerization tools like Docker and orchestration platforms, such as Kubernetes, are also vital. They manage microservices as containers, simplifying the deployment and scaling process. Additionally, infrastructure as code automates the setup of environments, ensuring consistency and speed in provisioning. Security is another important aspect. CI/CD pipelines enforce access controls and conduct vulnerability scans to keep microservices secure. Monitoring tools integrated into the pipelines provide logging and tracing, which help teams detect issues early on. However, there are challenges. Managing multiple pipelines can lead to complexity, especially with cross-service dependencies. To tackle this, teams often adopt modular designs and automate testing at the service level. In practical terms, CI/CD pipelines aligned with microservices architecture allow teams to deploy updates multiple times a day. This reduces lead times and speeds up recovery from failures. As the software as a service market trend continues to evolve, these practices support the demand for scalable and resilient software delivered continuously. In essence, CI/CD pipelines work seamlessly with microservices architecture and software as a service by enabling independent, automated, and secure delivery workflows for each service. This alignment is key to achieving agility and continuous improvement in software development.